Hey, what is up guys? Welcome to another video. In this video I'll be going over a paper I've put together made up of questions from past papers, and all of the questions are to do with algebra. So I thought this would be useful if somebody is trying to revise a particular topic. Then they can, rather than doing a whole past paper, they can just do this paper on algebra. And if you think this is useful, I could do one on data and probability and shape and number as well. These are the different topics that I'll be going over. So question 1 is on simultaneous equations, question 2 is substitution, question 3 is expanding and factorizing, question 4 is rearranging a formula, then inverse proportion, expanding brackets, graphs of equations with direct inverse proportion, quadratic graphs, there's an algebraic proof, change recurring decimals to fractions, iterations, algebraic fractions, graph transformations, completing square, graph transformations again, composite functions, equation of circle and tangent, upper and lower bounds. So all of these topics fall under algebra. So if you're looking to revise just questions on algebra, then this is the video for you. As I said, let me know if you think this is a good idea and I can do this on more topics. I will leave a link to the paper in the description, so you can go ahead and download the paper, have a go at it, and once you've had a go, you can come back and watch this video and go through your answers and check any misunderstandings you might have had, or just check your answers as you go through. I think that's all I wanted to say, so let's get straight into the questions. Okay, question 1 says solve the simultaneous equations 3x minus 2y equals minus 5 and 2x minus 4y equals 2. So one way to do this is called elimination, where you try to eliminate one of the variables by adding or subtracting the equations. And I am going to do that, but before we do that we have to make one of the variables equal, or the coefficients equal. The way I can do that is to multiply one of these equations so that either the x's are equal or the y's are equal. And because I've got a 2y here, or a minus 2y, and a minus 4y, I can multiply this equation by 2, and then this will become 4y, so I can eliminate that variable. So this becomes 6x minus 4y equals minus 10. You can see I've just multiplied every number by 2. And then the second equation stays the same. And now I can add or subtract these equations. Now the rule is, you look at the sign in front of the variable that has the same number, and if the signs are the same, you subtract. So usually we would say same sign subtract, or SSS. So I need to subtract these two equations. So we subtract everything in those equations. So 6x minus 2x, that's 4x. And then minus 4y minus 4y, that's minus 4y plus 4y. Those two negatives turn into a plus. And then a minus 4 plus 4, that's going to be 0. Equals minus 10 minus 2, that's minus 12. So now I've got 4x equals minus 12. So 4 times what equals minus 12? X must be minus 3. And then we can substitute that back into one of these equations. So I'll say using 2x minus 4y equals 2. I'll use that equation. I can substitute this minus 3 in where the x is, so this is going to be 2 times minus 3 minus 4y equals 2. So this is minus 6 minus 4y equals 2. I'll just bring it up here. And then add that 6 to the other side, so that's minus 4y equals 8. So y equals minus 2. Just divided that 8 by minus 4. So my solutions there are x equals minus 3 and y equals minus 2. Question 2 says s equals pi squared bracket b squared minus a squared A equals 8, B equals 10. Calculate the value of S. Give your answer correct to 3 significant figures. Okay, so we just need to substitute these values into that equation, and then basically this is assessing bid mass, so making sure that you know which operations to do first. So let's firstly substitute those values into this equation. So the pi square stays where it is, and then when we get to b, we need to write 10 squared minus 8 squared bracket. So we need to assess what's inside the brackets first. Because this is a calculator question, you can put this straight into a calculator and get the answer as it is. So let's go ahead and do that. So we've got a pi squared. Find the pi button on your calculator, and then squared bracket 10 squared minus 8 squared. Make sure everything's in the right place. Press equals, and we get 355.3057584, but it says give your answer correct to 3 significant figures. So the first 3 significant figures here are 3, 5, 5, and the next one is a 3, so that 5 will stay the same, it doesn't need to round up. So my answer here is 355. That should be an approximation sign, because it's approximately 355. Question 3 says Miriam is trying to expand and simplify n minus 2 all squared. Here is her working. So n minus 2 squared equals n minus 2 bracket n minus 2. That looks about right. Then she's got n squared minus 2n minus 2n minus 4. Looks a bit suspicious. N squared minus 4n minus 4. Miriam's answer is wrong. Find Miriam's mistake. So at the end here, she's expanded everything else correctly. She's done n times n, n squared, minus 2 times n, and minus 2 times n. But then she's got to minus 2 times minus 2, and she's written minus 4, but that should be a plus 4. So it should probably be okay that you circle it, but maybe you have to state something like minus 4 should be plus 4. Josh is trying to factorize x squared minus 6x plus 8. His reasoning is because 4 minus 2 equals 8 and 4 plus 2 equals 6, then x squared minus 6x plus 8 equals x plus 4, x plus 2. Explain what is wrong with Josh's reasoning. Well, the 4 times the 2 equals 8 is okay, but the coefficient of x here is minus 6, not plus 6. So we could say the coefficient of x is minus 6, not plus 6. So the factors need to sum to minus 6. And I give an example of an answer. So this would equal x squared minus 6 plus 8. The last part of this question says, Shona has to draw the line with equation y equals 3x plus 2. Here is her line. So here's the x-axis, here's the y-axis, and there's the line. Explain why Shona's line cannot be correct. Well, when you're given an equation of a straight line, the number on the end is the y-intercept. So because it's plus 2, and this line is clearly cutting the y-axis below the x-axis, so that will be a negative y-intercept. So my reasoning here would be that the y-intercept should be positive above the x-axis, something like that. So they were all just 1-mark questions, so don't need too much detail in your answers there. Question 4 says make t the subject of p equals the square root of a plus t on 2. Okay, so where should we start? Well, we need to get rid of that square root first. And what I like to do when I'm rearranging formula is to firstly get the subject on the left-hand side. So my first step here is to write this, to flip it around and then I'll square both sides, so this becomes p squared. So I square this side and it gets rid of the square root symbol. Then I want to get rid of this a, so I need to subtract it from the right hand side. So I've got t over 2 equals p squared minus a. And then I need to get rid of this denominator here. So this is t divided by 2, so I need to multiply the right hand side by 2. So t is going to equal 2 times p squared minus a. Question 5 says p is inversely proportional to the square root of m. P equals 10 when m equals a quarter. Work out the value of m when p equals 2. So when something is inversely proportional, we can use this symbol. So this generally means proportional to, and p will be inversely proportional to 1 over the square root of m. And when something is inversely proportional, as p increases, m will decrease, and vice versa. So that's the relationship when something is inversely proportional. And then we can turn this into an equation by introducing some variable k. So p will equal k divided by the square root of m. That's a pretty standard way of starting these proportion questions. And we can use this formula now to substitute in these values for p and m. That allows us to find k, and then once we have all of the values in this equation, we'll be able to solve for m. So starting off with p equals 10 and m equals a quarter, we can say that 10 equals k on the square root of a quarter, and then 10 equals k over, now the square root of a quarter is like the square root of 1 divided by the square root of 4. Square root of 1 is just 1 and the square root of 4 is 2, so this is k over a half. And then if you divide something by a half, it's the same as multiplying by 2. So 10 equals 2k. Also, you might know that as flip and multiply. So if you divide something by a fraction, you can flip it over and multiply. So then you get 2 lots of k as well. So if 10 equals 2 lots of k, then k must equal 5. Okay, so I have my value of k. And now I want to find m when p equals 2. So I can say that p equals 5 on the square root of m. And then, so therefore 2 equals 5 on the square root of m. And then when you want to get this variable by itself, you can kind of switch these over. In other words, or basically you're multiplying this side by the square root of m and then dividing the side by 2. So we can say the square root of m equals 5 on 2, and then we need to square both sides. So to get rid of that square root, so m is going to be 25 on 4. 5 squared is 25, 2 squared is 4. So you could leave it as that, or you could change it into a mixed fraction, and that will be 6 and a quarter. Question 6 says expand and simplify x plus 2 times x plus 8 times x minus 4. And what we can go ahead and do here is to firstly expand out these double brackets. So I'll use FOIL, in other words, multiply the first terms in the brackets. So x times x is x squared. Then multiply the last terms plus 8x. Multiply the inner terms plus 2x. Multiply the last terms plus 16. And then I've still got this x minus 4 at the end. And then multiply everything in these brackets by everything in those brackets. Actually, we still need to simplify this a little bit more, so that's going to be x squared plus 10x plus 16 times x minus 4, and then multiply everything in here by everything in here. So starting with the x squared times the x squared by x, so it's going to be x cubed. Then the 10x by x, so plus 10x squared. Then the 16 by x, so that's 16x. And then start again by multiplying by the minus 4. So minus 4 times x squared is minus 4x squared. 10x times minus 4, that's minus 40x. And then 16 times minus 4, that's minus 64. Okay, and then we need to simplify, so there's no more x cubed, so that will just be x cubed, and then 10x squared minus 4x squared, that will be 6 plus 6x squared, and then we have 16x minus 40x, that will be minus 24x, and then we have this minus 64 in the end. And we can't simplify any further, so that's my final answer there. Question 7 says, here are 5 graphs. Each graph shows either direct proportion or inverse proportion. Okay, so we have our graphs here, and then the rest of the question says, the table shows 5 equations. Match the letter of each graph to its equation. Okay, so let's have a quick look at these graphs. This is what sometimes we call a hyperbola, where you have a curve up here and a curve down there. Here, this is clearly a straight line graph. This looks like if you took a quadratic equation and laid it on its side. This is clearly a quadratic equation, and this is what a cubic looks like with a squiggle in it. Okay, so this is actually the only graph with an inverse relationship. This looks very similar to the graph y equals 1 on x, where you get these two curves in the two different quadrants. And so what I'll be looking for is an equation that looks like y equals 1 on x. And here it is, y equals k on x. So that's the only possibility for A. So I'm going to go ahead and write A in there next to y equals k on x. Straight line graph, it's pretty simple, so that must be this one, y equals kx. This sideways quadratic, that's if you think about the graph of a quadratic where y will equal x squared something, if you do the inverse of that, x equals the square root of y, this is the kind of graph that you get. So I'll be looking for a square root here somewhere, so that's y equals k square root x, so that will be graph C. It's kind of like, try to think of it as the inverse of the quadratic, so you kind of lay it on its side. This is a quadratic equation, so I'll be looking for an x squared somewhere. Here it is, y equals kx squared, that's D. And then the only one left is E, the cubic equation. X cubed is E. Question 8 says a particle P is moving in a straight line. O is a fixed point on the straight line. The distance s meters of P from O at time t seconds is given by s equals 80t minus 5t squared. Use algebra to find the greatest distance of P from O when t is between 0 and 16 seconds. When I first read this question, it was kind of a bit of word spaghetti. I read it, but nothing really went into my head. So it took me a couple of minutes to really make sense of what was going on. So we've got a particle moving in a straight line, and it starts at O, and then it moves some distance away from O, and the distance is given by the time it's taken to get there. And this is kind of represented by this graph. So you could think of it actually as throwing a ball in the air, where the distance away from your hand is represented by s. This is the distance, and this is the time. So as the time increases, the distance gets more and more, and then as the ball starts to fall, the time is still increasing, but the distance is going back down into your hand again. So hopefully that analogy will help you to make sense of this question. But also you could just look at this graph and treat it as any normal quadratic. So the first thing you need to do is to identify where will the greatest distance be. Well, that will be at the top of this graph here. If s is the distance from O, then we want the highest possible value for s. So we can start off by saying that the the vertex or maximum will be the greatest distance. Okay, so we're looking for that point of the vertex or the maximum of that graph. To find that, we can find the distance halfway between where the graph cuts the time axis, or the solutions, or what we would usually call the roots of this graph. And that will be when s equals 0. So when the graph cuts the t-axis, s will equal 0. So we can say when s equals 0, 80t minus 5t squared will equal 0. And then we can factorize this side. So if we take 5t out of both terms, 80 divided by 5, that's 16. And then we're left with just t here in this term. So 5t times 16 minus t equals 0. And then therefore t can equal 0, or 16 minus t equals 0. And then if 16 minus t equals 0, well, minus t will equal minus 16, so t will equal 16. Okay, so when the distance is 0, in other words, when the ball's in my hand, that will be when at time 0 before I've thrown the ball, and then it will take 16 seconds for the ball to land back in my hand. Okay, so the greatest height, or the greatest distance of P will be halfway between those two times. So we can say the maximum. So the maximum will occur at t equals 8. So when t equals 8, s equals 80 times 8 minus 5 times 8 squared. And this is a non-calculated question, so we need to work this out without a calculator. So 8 times 8, that's 64. So 80 times 8, that will be 640. And then this is going to be 5 times 64. 8 squared is 64. And then, well, let's do a quick multiplication over here. 64 times 5, that's 20. Carry the 2. 6 times 5 is 30. Plus 2, that's 32. So 64 times 5 is 320. So we end up with 640 minus 320, which will equal 320. So the greatest distance of P from O will be 320 meters. Question 9 says, for any 3 consecutive whole numbers, prove algebraically that the largest number and the smallest number are factors of the number that is 1 less the square root of the middle number. Okay, another kind of word spaghetti type of question, but let's break this down and then work it out. So we're told that firstly any 3 consecutive whole numbers, and we need to prove something algebraically. So the first thing I'm thinking is, how can I represent 3 consecutive numbers algebraically? So we're talking about consecutive numbers are one after the other, so 1, 2, and 3 are consecutive numbers. So how could I represent those algebraically? Well, if I called the first number x, the next one will be x plus 1, and the one after that will be x plus 2. You could also do it as x minus 1, x, and x plus 1, and you'll still get the same result. I'm going to use this method, but you'd be fine doing it that way as well. And then we need to prove that the largest number, so that would be x plus 2 in this example, and the smallest number, that would be x, are factors of the number that is 1 less the square of the middle number. Okay, so this is the middle number here, and we need to square that, and then we need to subtract 1. Right, so let's just do that first. Let's take that middle number, x plus 1 squared, take 1, and let's expand this out and simplify it. and see what we get. So let's expand these brackets here. So x plus 1 squared, that's going to be x squared plus 2x plus 1, and then we've also got that minus 1 on the end. So that plus 1 and that minus 1 actually cancel out. So we're left with x squared plus 2x. That is the middle number of my consecutive numbers squared and taking one away, which is x squared plus 2x. Then I could factorize that, so take x out of both terms, and I'd get x times x plus 2. Okay? And then you might notice something, that if we look back at my consecutive numbers written algebraically, I had x and x plus 2 as my smallest and largest numbers, and the middle term squared subtract 1 is x times x plus 2, so they must be factors of this term. I'm basically multiplying them together. So I could say something like the middle term squared minus 1 equals the first and last terms multiplied. And in that case, therefore, they must be factors. Therefore, they must be factors. Okay, question 10 says, prove algebraically that the recurring decimal 0.457, where the 5 and 7 are occurring, can be written as 151 divided by 330. Okay, there's a very clear method to these types of questions that once you get the hang of, then you'll be able to answer any of these types of questions that you come across. So I'd suggest learning this method because there's a definite chance that one of these questions will come up in the exams. So the first thing we do is to make x equal to the recurring decimal. So we say x equals 0.457 recurring. And then what we want to do is to create some numbers where the recurring part of the number is the same. So I can multiply both of these by 10. So 10x equals 4.57 recurring. And then I want to multiply it again by something so that I get another number with these recurring numbers the same. So if I just multiply this by 10 again, I'll get 45.75 recurring. That's no use because I can't then eliminate the recurring decimals. So what I can do is multiply it by 100. So I get 1000x equals 457.57 recurring. And now the decimal parts of these numbers are equal. So I can subtract these two equations. So I get 1000x minus 10x equals 457.57 recurring minus 4.57 recurring. And what that allows us to do is to essentially eliminate these recurring decimals. So 0.57 recurring minus 0.57 recurring just gets rid of them, and then I just have to deal with whole numbers. So 1000x minus 10x, that's 990x, and then 457 minus 4, that will be 453. So then we can say that x equals 453 divided by 990, and then look back to the question and have a look at the fraction we're looking for. So we're looking for 151 divided by 330. So if I divide 990 by 3, that will give me 330. And then 453 divided by 3, let's see what that is. So 3 goes into 4 once, carry the 1, 3 into 15 is 5 times, 3 into 3 is 1. So 453 divided by 3 is also 151. So that would be how you go about proving that that recurring decimal equals a fraction. As I said, a useful method and something that often comes up in exams. Question 11 says, show that the equation x cubed minus 3x squared plus 3 equals 0 has the solution between x equals 2 and x equals 3. So this is a typical iterations question where they give you a cubic and two values of x and they ask to show that there's a solution between them. So all you need to do for these questions is substitute those values of x into the equation, find what it equals, and then if the sign changes, there must be a solution between them. Okay, so let's substitute x equals 2. So when x equals 2, this will be 2 cubed minus 3 times 2 squared. All I'm doing is substituting this 2 into this equation here. So 2 cubed minus 3 times 2 squared plus 3, and then figure out what that equals. So 2 cubed is 8, 2 squared is 4, so that's going to be minus 12 plus 3, and then 8 minus 12, that's minus 4 plus 3, which is minus 1. And then substitute in x equals 3, so when x equals 3, 3 cubed minus 3 times 3 squared plus 3, and then figure out what this equals. So 3 cubed, that's 27. 3 times 3 squared, that's minus 27 plus 3. 27 take 27 is 0, so we just end up with 3 there. So you can see that when x equals 2, we get a negative value, and when x equals 3, we get a positive value. So we can say as the signs change, there must be a solution between 2 and 3. Part B says, show that the equation x cubed minus 3x squared plus 3 equals 0 can be rearranged to give x equals the cube root of 3x squared minus 3. Okay, so let's start off with just writing it out again. I guess you don't really have to do this, but I always like to start off with this first line. And then we're looking to get x by itself here, so let's start off by adding this minus 3x to that side and subtracting this. So we get x cubed equals 3x squared minus 3, and then we need to get rid of that cube. So the way we do that is take the cube root of both sides, so then x will equal the cube root of 3x squared minus 3. That's all you really need to write for these types of questions. Part C says, starting with x sub 0 equals 2, use the iteration formula x sub n plus 1 equals the cube root of 3x sub n squared minus 3 to find the value of x2. Give your answer correct to 3 decimal places. So I have done a video on iterations and I talk about what this notation means, but basically we need to substitute the x0 into this equation to find x1, and then take the value we get for x1 and substitute it into the equation again to get x sub 2. So if we substitute 2 into this equation, we get the cube root of 3, and then we get to the x sub n and we put in 2. So 2 squared minus 3. I like to put brackets sometimes around the things I substitute in just to make it clear the change that I've made. You don't have to, but I think it makes it really clear where you're putting the number in. And this is a calculator question, so let's just go ahead and put that straight into our calculator. So I have a cubed root button. If you don't, you should have this button where it has an empty box, and you put the 3 in, and then let's just use some brackets just in case. So this will be 3 times 2 squared minus 3, and then end the brackets, and we get 2.080, etc. 2.080. And then to find x sub 2, which is what we're looking for from the question, take that value, substitute it into the formula again. So that's going to be the cube root of 3 bracket 2.080 squared minus 3. And something I didn't talk about in my video on iterations is this idea of just using the answer key on your calculator. So if you put that into your calculator again, so let's do the cube root of 3, and then you can use the answer button, which is usually above the minus sign. Shift answer squared minus 3. And I'll just put brackets in just in case. And that's going to give you, instead of just putting that number in, you can just press answer and you get 2.153 equals 2.153. And the question says give your answer correct to 3 decimal places. And so that's all we need to do. We don't need to round up because the next number is a 0. So x sub 2 equals 2.153. Question 12 says x squared minus 9y squared equals 0, where x is greater than 0 and y is greater than 0. Work out the ratio of x to y. Okay, so let's start off by writing this down again. X squared minus 9y squared equals 0. And then we could say that x squared equals 9y squared, because I've just added that to the right hand side. And now we can take the square root of everything, and we won't have to worry about pluses and minuses because we're told that x is greater than 0 and y is greater than 0. Typically, if you have the square of some unknown, let's say x squared equals 10, to find what x would equal, you'd have to do plus or minus the square root of 10. However, in this example, because we're told that x and y are greater than 0, we can take the square root of everything in this equation and we don't have to worry about these pluses and minuses. So the square root of x squared is just x, square root of 9 is 3, and the square root of y is just y. So x equals 3y. So let's say x equaled 6. We'd have to multiply something by 3 to get 6, so y would equal 2. So the ratio here of x to y is 3 to 1. So x is 3 times larger than y. It's maybe, I could see where people could make a mistake here by saying the ratio is 1 to 3 because we've got 1 lot of x and 3 lots of y. But this is actually saying that x is 3 times greater than y because we need to multiply y by 3 to get x. So the final answer there is x. The ratio of x to y is 3 to 1. Okay, part B says simplify fully. 3 minus 4x squared divided by 2x squared minus 7x plus 3. And well, we've got two quadratics here and we can factorize those and hopefully something cancels out and we're left with the more simple fraction. Okay, so let's start with the top line. I'm just going to rearrange it so the x squared is at the front. I find it easier to do when it's written like that. So top line becomes minus 4x squared minus 4x plus 3. And the bottom line, I'll just leave it as it is, 2x squared minus 7x plus 3. And I'm also going to take a negative 1 from the top line because I also find it easier when the first term is not a negative. So this becomes minus bracket 4x squared plus 4x minus 3. And then the bottom line, let's have a look at the bottom line first. So 2x squared minus 7x plus 3, I need to factorize into 2 brackets if possible. So I need some factors of 3 where 1 is multiplied by 2 to make minus 7. Well, the only factors of 3 are 3 and 1. And if I multiply 3 by 2, that would be 6. And if it's minus 6 minus 1, that would be minus 7. Okay, so my terms here could be 2x and x. And my last numbers, now the 3 needs to match up with the 2x, so the 3 needs to go at the end of this bracket. And they're both negatives. and this will be a -1, so they're both negatives. -1 times -3, that will make +3. Minus 6x minus x, that will be -7, and 2x times x, that's 2x squared. So I've factorized the bottom line. Okay, now let's go ahead and factorize the top line. So let's just leave it as it is on the bottom for now. And then on the top line, I've got 4x squared plus 4x minus 3. Again, the only factors of 3 are 3 and 1. And I need to make +4. Well, I could do 3 plus 1, that would make 4. However, we have this coefficient of x squared. So if we break that into 2 and 2, and I've got the factors of 3 and 1, so if we multiply 3 by 2, that's 6, and 2 by 1, that's 2. How can I make +4 out of 6 and 2? Well, 6 minus 2, that's +4. So the 1 needs to be negative in those brackets. So the 4x squared becomes 2x and 2x, and then the my factors there are 3 and -1. And then quickly, if you want, maybe in your head or in some quick notes, do an expansion again just to make sure it equals the same thing. So 2x times 2x, that's 4x squared. 6x minus 2x, that's 4x, and then -1 times +3, that's -3. And then I still have that negative there. Alright, so I factorized the top and bottom lines. Is there anything we can cancel? Yes, there is. There's 2x minus 1 and 2x minus 1. So what I end up with on my next line is negative 2x plus 3 divided by x minus 3. And there's still something I can cancel. There's a -1, so this negative out the front here. If I take -1 from the bottom line, it becomes, if I factorize the -1, I effectively need to change the signs of both terms. So the -3 becomes a +3, and the plus x becomes a minus x. And then I can cancel those -1s, and this becomes 2x plus 3 over 3 minus x, and that's my final answer. Question 13 says, here is a sketch of the curve y equals sine of x plus a plus b. Given that a is between 0 and 360 degrees, find the value of a and the value of b. Okay, so let's look at the typical equation of a sine curve. You may have seen it written like this before, but typically a sine curve, it can have some term in the brackets, and it can have something added on the end. So here I've written capital letters to represent all of the values that appear in the equation of a sine curve. So all of these values do something different. So the A represents the amplitude, and this is basically the height of the curve from the x-axis, or the midpoint of the curve. So in this example, because the curve's been shifted, the midpoint is actually here, and the amplitude is that vertical distance between the midpoint and the top of the graph. If you took the total height of the curve, it would just be half of that. So from the very top to the bottom, it would be half of that distance. B here represents the period, or helps you to calculate the period. The period is where the curve starts repeating itself. So in this case, the period is from 0 to 360, because you can see it's gone down to 180 and up again, and it will start over again. So the period is how long the curve takes to start repeating itself. C is the phase shift, which is a fancy way of saying the horizontal movement to the right. So if I drew a new curve on this graph, so let's say the curve, I shifted the graph horizontally this way, we would call that a phase shift to the right. So it's just shifting the graph left or right. So that's what C represents in this equation. And you can see here A in the question is corresponding to C in my little equation here. So, and then D is the easiest one I think to deal with, is the vertical shift. And that's just a simple up or down movement. Okay, so there are all of the different variables in the equation of a sine wave. And in this case, we need to worry about the phase shift, in other words, the left and right movement, and D, or the vertical shift, which is the number on the end. Okay, the other thing you need to know about this for this question is what a typical sine wave looks like. So a normal sine wave will go up to 90 and then down to 180 and then down to 270 and up to 360 again. So that's a terrible curve, but hopefully you get the idea. It starts at 0 and goes up and down like that. And you can see here clearly the graph has moved down. So this point it has shifted down by 1. So where it was at usually at -1, it's now at -2. So that will tell us the vertical shift. It's gone down 1, so we can say that B will be -1. It's as I said, the vertical shift isn't as complicated. If it went up 1, you just say it's +1. So the vertical shift isn't too bad. Then we need to think about which way it's shifted, left or right. So actually let's look at this one. So typically the curve would go up to 90 and start going down again. That point has shifted this way to 0. So this would be the new tip of this curve. So it shifted across from 90 to 0. So it shifted left 90 degrees. So let's just write that out. So shifted left 90 degrees. And in this equation, it's written as -c. So if it's a negative, that shifts it right. And if it's a positive, it shifts it left. So that will be positive 90 degrees. And that's where it gets a bit counterintuitive. That's why I say the vertical shift's a bit easier, because if it goes down, it's negative. If it goes up, it's positive. But the horizontal shift, if it's positive, it goes left. If it's negative, it goes right. So A there will be a positive 90 degrees. Question 14 says x minus 8 bracket x plus 4 equals x minus a squared plus b for all values of x. Find the value of a and the value of b. So this is a typical completing the square question. The first thing, actually, you're usually given this as a quadratic, so we have to expand these brackets out first. So this is going to be x squared plus 4x minus 8x minus 32, which equals x squared minus 4x minus 32. And then what we need to do is to break that quadratic into two identical brackets and then figure out what to add on the end to make it equal. So the way we do this is to half the coefficient of x in the middle, so that the two double brackets are the same. And an easy way to think about it, as I said, is to half that middle term and now the second term in the bracket. So half of minus 4 is minus 2. So I get x minus 2, x minus 2. And that's why we call it completing the square, because we need to create a squared term in these brackets. So then make a quick note to yourself and expand these brackets out again. And what would that equal? This would be x squared minus 4x plus 4. But we need a negative 32. So what's the difference between plus 4 and negative 32? In other words, what do I need to subtract from 4 to get negative 32? And this will be negative 36. So 4 minus 36 is negative 32. So to make x squared minus 4x minus 32 equal to x minus 2, x minus 2, I need to take away 36. Once I've expanded those out and I subtract 36, it would equal this. Okay, so the whole point is to now have two identical brackets which I can write as squared brackets, so x minus 2 squared minus 36, and then we have our a and b terms. So a in this case is 2 and b is negative 36. Question 15 says the graph of y equals f of x is shown on the grid. Part A says on the grid sketch the graph of y equals f of x minus 1. So when you take away 1 from the variable in the equation like this, you're shifting the graph to the right. So you could do a quick example to yourself. You could do the graphs of f of x equals x, and then f of x minus 1 equals x, and do a quick table of values. So if x is 1, 2, 3, 4, 5, f of x, that's just saying f of x equals x, so this is going to be 1, 2, 3, 4, 5. F of x minus 1, you need to subtract 1 from each x value. So if x is 1, subtract 1 to get the y value, that would be 0. And then 2 minus 1 is 1, 3 minus 1 is 2, 3, 4. So you can see, if we plot these quickly, f of x equals x, that's the same as y equals x. That will be 0, 1, and 1, 2 and 2, 3 and 3, etc. Just like that. And then for f of x minus 1, when x equals 1, y is now 0. When x is 2, y is now 1. So you can see for every x value, the y value has shifted down, or you could think of it as for every y value, the x value is shifted to the right. So that's the effect of subtracting something inside the brackets there. I like to try to have specific examples in mind of the different ways to shift a graph, because sometimes it's easy to get mixed up, and if you can just think of that specific example, then maybe it makes it slightly easier to remember. So I need to shift this whole graph to the right, so it's going to end up as best I can, something like this. Okay, so this is f of x minus 1. Okay, the second part of this question says the graph of y equals f of x has a turning point at the point minus 1, 1. Okay, that's there. Write down the coordinates of the turning point of the graph y equals f of minus x plus 2. Okay, so that minus x, what that actually does is to reflect the graph in the y-axis. So reflect in y-axis. And I might use a graphing application just to give some examples. So f of minus x, the only term in a quadratic that changes is the middle term. So x squared, if I change the x value to a negative, x squared won't change. But if I have an x term, let's say 2x, actually change it to 6x plus 3, it will change that term in the middle from a minus to a plus. So this is the graph of x squared minus 6x plus 3. And then if we do x squared plus 6x plus 3, that's effectively saying f of minus x of this graph here, x squared minus 6x plus 3. And you can see here that it's reflected in the y-axis. Also, you could think of it as shifting the number of units of the coefficient left or right, but I think it's easier to think of it as a reflection in the y-axis. So that's if you change the sign of the x here. So if that becomes f of minus x, then you reflect in the y-axis. And plus 2, that's just a vertical shift up. So the graph would shift up 2 and reflect in the y-axis. So it'd be here. And the new turning point would be up here. So the new turning point would be 1, 3. Question 16 says f of x equals x cubed, g of x equals 4x minus 1, and part A says find f g of 2. So this is basically saying substitute g of 2 into f of x. So first we need to find g of 2. So that's going to be 4 times 2 minus 1. So I've taken this function, substituted 2 into it to get g of 2. So that's going to be 8 minus 1, that would be 7. And then we take that value of g of 2 and substitute it into f of x. So f of 7 will be 7 cubed. And 7 cubed, that is 343. So f of g of 2 is 343. Second part of the question says h of x equals f g of x. Find an expression for h inverse x. Okay, so f g of x, that's saying that I've substituted g of x into f of x. In other words, take this expression and cube it. So f of g of x is going to be 4x minus 1 cubed. So I've taken this equation or expression and substituted it into this one. So then h of x equals 4x minus 1 cubed. Okay, now we need to find h inverse x. And the way we do that is to start off, we say that let h of x equals y, just to make it easier to rearrange. So we say that y equals 4x minus 1 cubed. And then what we want to do is to solve for x. So I want x by itself on the left-hand side. And this is why it's called the inverse, because we're kind of inversing the whole function. So the first thing I need to do is get rid of this cubed, this power of 3, so I can take the cube root of both sides. So the cube root of y equals 4x minus 1. Actually, I don't need those brackets there anymore. So I've got rid of that power of 3. And then I can add 1 to this side. So the cube root of y plus 1 equals 4x. Then I'm going to flip the whole thing around and divide by 4. So x equals cube root of y plus 1 divided by 4. And now we've got x equals something y. All we need to do now is to change the variable so that x becomes h inverse of x and the y becomes x. It's a little bit confusing as to why they change back, but that's the general idea of inverse functions. So this now becomes the cube root of x plus 1 over 4. My final answer there is cube root of x plus 1 divided by 4. Actually, make that a bit clearer. Cube root of x plus 1 divided by 4. Question 17 says the diagram shows the circle with equation x squared plus y squared equals 261. A tangent to the circle is drawn at point A with coordinates p minus 15 where p is greater than 0. Find an equation of the tangent at A. Okay, so here's A, and we need to find an equation of this line. So the first thing we need is a point on the line, and we're given part of a point, but we need to find P. Well, the tangent touches the circle at A, so that means we can use this equation to find X, because this point, P minus 15, will also be a point on this circle. So to solve for P, I could say that P squared what I'm going to do is substitute these points into this equation and then solve for p. So p is x, so put p in where the x is, and then y is minus 15, so that's going to be minus 15 squared equals 261. And then p squared plus 225 equals 261. So the negative 15 squared becomes a positive, and 15 squared is 225. And then p squared equals 261 minus 225. So p squared equals, that's going to be 36, and then p equals 6. And here I don't need the plus or minus because they've told me p is greater than 0. So I have a point on the line. So a equals 6 minus 15. And now I need a slope. So one way I could work out the slope is to look at the radius of the circle. And now I know the x value and I know the y value, so I could say that I could find the gradient using the rise over the run. So the gradient of the radius equals the rise over the run. Now what I'm doing is using this point 0, 0 and using this point 6 minus 15 to find the gradient. So that would be y2 minus y1 over x2 minus x1. Y2 is minus 15, x2 is 6, and they're both minus 0. So it'll be the gradient of that radius from 0 to a will be minus 15 on 6. And now a rule about tangents is that they meet the radius at 90 degrees. This is always the case. So, and also there's a fact about lines at 90 degrees is that their gradients will be negative reciprocals of each other. So we can say, now we have the gradient of the radius, we can find the gradient of that line, that tangent. So we can say the gradient of the tangent will equal the negative reciprocal of minus 15 on 6. So we flip it, we flip that fraction and we change the sign. So the gradient of the tangent becomes 6 on 15. So that's the negative reciprocal. Now I have a point on the line and the gradient. I can go ahead and find the equation. So starting off, I can say the equation of the tangent will look something like this, where y equals the gradient times x plus some number c, which will represent the y-intercept, where the line cuts the y-axis. And to solve for c, I need to substitute in the point a. So I can say using a equals 16 minus 15. Substitute those values into this equation. So minus 15 goes to where the y is, so this will be minus 15 equals 6 on 15. Actually, 6 on 15, that simplifies, doesn't it? So we divide both by 3, that will be 2 over 5. So let's use that instead. It'll be much easier. So 2 on 5 and 2 on 5 times x plus c. Oops, and then I meant to put in 6 for x, so substitute in that 6 where the x is, and then start solving this for c. So we get minus 15 equals 12 on 5 plus c. Then we can multiply everything by 5. So 15 times 5, that's 75 equals 12 plus 5c. So 5c equals minus 75 minus 12. So 5c equals minus 87, and then c equals minus 87 on 5. Okay, so I think that would make more sense to have as a decimal, so let's put that into our calculator. So minus 87 divided by 5, that gives us minus 17.4. Okay, so we have c, therefore the gradient of the line will be y equals 2 on 5 x minus 17.4 for your final answer. Okay, so what do we do there? Firstly we found p using the equation of the circle. Then we found the gradient using the gradient of the radius and the tangent and the negative reciprocal. Then we used the point A again to find the y-intercept, and then that gave us our final answer. Question 18 says m equals 1 over p times s. P equals 5.37, correct to 2 decimal places. S equals 2.9, correct to 1 decimal place. Calculate the upper bound for the value of m. You must show your working. Okay, so the trick here is that because m equals 1 over p times s, we can't just take the upper bounds of these numbers and plug them in, because you need to think if we want the highest value of m, we want the lowest value of p and s. If you want to think about it like this, you could say that 20 divided by 10 equals 2, and then if I decrease this number, this denominator, so 20 divided by 5, that equals 4, then the answer goes up. So if I have the lowest possible value for p times s, then I'll have the highest value for m. So we actually need the lower bounds for p and s there. Okay, so let's write down the lower bounds of p and s. The lower bound of p is 5.365, so that would round up to 5.37. And the lower bound of s, we need the number that would round up to 2.9, and that would be 2.85. So they're my lower bounds, and then I can say that m will equal 1 divided by 5.365 times 2.85, and then get the calculator out again. So we do 1 divided by 5.365 times 2.85 bracket equals 0.0654, and they haven't given us a degree of accuracy, which is strange, so I'm going to write out the whole thing and leave that as my answer. So 0.6540 115,433, and that's my final answer, because they haven't told us to round it off to anything. Okay, so that's all the questions I'm going through in this video. I hope you found that useful. Again, let me know if you like this idea of putting questions together by topic. I could do another one on geometry or shape or data or whatever topics come up in exams. In my opinion, this would be useful for revision. This is kind of how I might revise. But let me know what you think. Leave a like if you appreciated this video. Subscribe if you want to see more content, and I'll see you in the next one. Bye for now.